This is another video in Fundamental of Electrical Circuits sequence. Here what we're going to do is we're going to focus on analyzing these three-phase circuits, but really focusing on an area which sometimes causes confusion is what's a line voltage, what is a line voltage, a line current, and what is a line phase voltage and phase current. So there are four quantities you got to be aware of. So let me go ahead and write these down. So we've got in this kind of a phase, we have conversations about line voltage, phase voltage, and then line current and phase current. So as we discussed earlier, phase refer to a single one of these these loads, the voltage across one of the loads. So if, by the way, if they don't mention anything, they're talking about load because that's what the importance is. So sometimes you're asked to look to find a phase voltage, and so phase voltage could be basically if this is N, this is the neutral one. So one phase voltage could be VAN. Another phase voltage could be VCN, or another phase voltage here would be VBN. So that's a phase voltage. So phase voltage are any of these one. For phase A would be VAN, VBN, and VCN. Now, line voltage, on the other hand, would be from this line to this line. Of course, neutral we don't go to. So it's going to be from A to B. That's one line voltage. A to C, another one. B to C, another one. And line current, it refers to the current line. By the way, the word line refers to the transmission line. So the line current is the current through the transmission line, which in this case for phase A is IA for IBB and ICC for phase C. Now, and then the phase current refer to the current in each one of the phase. So as you can kind of see in the case of a Y load, Y connected load, these two are equal to each other. So line current and phase current in a Y connected load is the same, as you can see here. But the voltages are not the same. So, and then of course, you know, we can, for example, if somebody gives me ZLA and a phase current, I can just multiply those two together and find VAN. That's pretty straightforward. Or if they give me the transmission voltage VAA, and they give me a current, I can find ZTA. So all the rules we've learned about KCL, KVL, and the fundamental relationship of Z, which is V over I, all of that applies here, so you can derive different quantities from each other. As we had talked a little earlier, when we are analyzing this one and we are trying to find phase voltage and phase current, the easiest thing is to just treat one of, just focus on one phase, and once we found that, just shift it by 120 degrees to find all the other phases. That process is referred to as a single phase analysis, and you basically literally take one phase out and redraw it, which we did over here. So this techniques, basically, if I'm given enough information, I can find IA, I can find VAN, which we usually write as a V phase, because magnitude, that's a magnitude of a phase. It usually fees you to refer to the phase with angle of 0 because it's A is the reference phase and it's always angle is 0 degrees. So once I use this circuit to do all my analysis to find it, so once I have VAN, finding VBN and VCN, all I have to do is remember which kind of a phase sequence I have, and based on whether it's an ACB or ABB, I would have one of these will be plus 120 and the other one will be minus 120. Okay. Now, this is kind of, so that's how we find the phase information. So now we already know that the IA in here is both the phase and line current. They are the same, so I don't have to really worry about any conversion. But we know that what we found here is the VAN. So how would I find VAB or VBB when, if they were asking me to find the line voltage, which would be if line transmission line to transmission line, which would be V to A to N. So how do I do that? I'm not going to go through the process here, but basically if you look over here, for example, VAB simply is going to be VAN plus minus VBN, or VAN plus NB, but basically it's going around the loop doing a K. If you do the KVL, you're going to be minus V, depending on which way you go. If you go this way, it's going to be VAB plus VBN plus VAN has to be equal to 0 as you go around the loop. So you end up with these kind of equation. VAB, the line, this is a line, this is a line voltage set is equal to the two phase voltages subtracted. Phase voltage is the magnitude of 0 with the magnitude of that. This must be the positive sequence, which is fine. So and then once you do a little cleanup of this one, you will find out this is the answer. And then most of the time we write it like this. So once I have VAN, I shift it by 30 degrees and I put a square root of 3 in front of it. I've got the line voltage. This is a good thing to write down someplace so you remember it. If I have a phase voltage, all I have to do to convert it is multiply by square root of 2 shifted by 30 degrees. And that same thing pretty much worked with all the other phases as well. So if I wanted to find, for example, the BC phase, all I do is take the BN shifted by 30 degrees and add the 30 degree shift on it. So here is for example a phasor diagram representation of what we just did. So VAN, these are the this is kind of the reference A phase voltage, and that basically is the line voltages for different lines. So this is the line voltage. And again, remember that as we discussed, line current and phase current are the same thing in the Y connected. That was in case our circuit was a positive ABC. And if you look at it for the negative, the only thing that happens for the negative phase is if you notice the shifts, instead of being in the positive direction than in the negative direction, they still get multiplied by square root of 3, but they go in the negative direction. So instead of being a square root of 3, Cn 30 would be minus 30, and that's really the only difference that happens here. That brings us to the end of here. The main thing we talked about is kind of getting a little more focused on line current, line voltage, phase current, and phase voltage for the Y connected circuit.